Your research aims at better understanding the processes that are involved in the activation and deactivation of catalysts.
Yes.
Would you like to describe your current research and the challenges that you would like to address with it?
Yeah, challenges, there are plenty of challenges, first of all, because catalysis is a very complicated process, and it is important to develop catalysis to a much higher level than is done nowadays. What we want to understand here is, from the very fundamental point of view, what are the important processes which occur? What makes the catalyst good? What makes the catalyst bad? What kills the catalyst? Because many of the catalysts deteriorate during operation. We use a very simple reaction process. It's oxidation of carbon monoxide. And we use a platinum substrate on which we deposit some catalyst material, and then vary parameters to understand what is making the catalyst work, what makes the catalyst lifetime long, and to understand the individual processes. We are looking at the catalyst before the reaction and at the catalyst after reaction. And here comes CERIC into the picture, because here we cannot look at the catalytic reaction by itself, because we need good vacuum here. And catalytic reactions require high pressures. So in order to look at the catalytic reaction by itself, we need an instrument which can operate at high pressures. And this is now where CERIC comes in Prague. So I have an instrument which can be operated at high pressure, and I will look there at the reaction itself. Here, before and after, and there during. I think combining this instrument with the one in Prague should be sufficient to really nail down what is going on in this particular catalytic process.
In the beginning of the 60s, you have invented an important instrument that we have here in its upgraded version, that is the low energy electron microscopy. If you would like to spend some words about this invention and about its developments, some also anecdotes, we would be pleased to know about it.
Actually, the only anecdote is the one that the first system was built out of glass. I knew it wouldn't work, because in a glass instrument you cannot achieve the precision which you can achieve in a metal instrument. So I knew it wouldn't work, and also it didn't work because it broke right away. Whenever you wanted to change something, a filament or so, you had to cut it open. The glass blower had to blow it together again, and it didn't work. I got permission from the director of the institute, a Navy laboratory, which was building actually rockets. And I had to convince him that a microscope like this is very important for rocket science, developing rockets. Anyhow, I got his permission. The instrument was built in the 1960s. It was in the United States, was then transferred to Germany, was sitting around for a long time because it takes good students to build something like this. And then in the mid-1980s, I had a good student, and he got finally his instrument working. This instrument was still without an energy analyzer. Here, this one has an energy analyzer here. It has many aspects here which were added later on, which makes the instrument now so unique. So this is, in my opinion, the worldwide best instrument of this kind.
A question that is made very often by non-scientists, for example, the general public, of course, and policymakers or journalists also, is what do you think is the impact that your research can have, may have, or will have?
Take the example of catalysis. For example, in the United States, 20% of the power which is used in the country, and which produces a lot of greenhouse gases, is used by the chemical industry. And if chemical industry can make the catalyst more effective, a tremendous amount of power can be saved. Or another example, solar cells. Originally it was silicon which was used. Nowadays there are many compounds which are used in order to optimize it. Research is needed, and this is also an important field. So there are many areas in the technical fields where this research really is providing the basis. It doesn't produce directly practical results, but the practical results require first some understanding to optimize the systems which are of practical importance. So it's important for communications, but communications doesn't use so much power except for the big servers, which are big power consumption. But really it's environment, which is the important part.
As an experienced scientist, let's say as a senior scientist, what kind of suggestions would you give to early stage researchers that are really at the beginning of their career?
First of all, have an open mind, that's number one. Number two, try to, if you want to advance, try to follow a little bit the trends, and the trends means don't do some, it's not so important how good the research you are doing, it's more important to produce many papers. Unfortunately, that's a very unfortunate development, but it's a way nowadays that young people are evaluated as a number of papers. When I was this age, there was no pressure to publish. You could do research, could really look into details without having to think about, can I produce a paper very strong? So this is disadvantage today. But one of these, my two recommendations are, first of all, keep an open mind, but at the same time follow the trend which you have to follow in order to advance. Once you have reached a certain level, then you can sit down and do real research.
What do you think that are the advantages for research that there are in US, for example, in comparison to Europe, and in Asia, in comparison to Europe?
I would say nowadays, for basic research, Europe is much better than the United States. The United States is very much driven by technology. If you want to get money from the research supporting organizations, you have to show that this is of practical importance. And people, of course, then build up big stories in order to give this impression, in order to get money, but they want to do basic research. That's one aspect. And the second aspect, which makes it difficult now in the United States to get money for a difficult research project, is the fact that in the United States you also have to demonstrate that you are educating a lot of people, usually undergraduate students. And undergraduate students cannot do real research here. So it's difficult to get money, for example, in basic research in the United States. It's much, much easier in Europe. In Japan, it was very good in Japan, maybe 10 years back, but Japan is now also getting more oriented to the American system as far as research support is concerned. I visited recently China, and I have the impression in China there's a lot of money for research, and they don't have to justify too much the application side. But the United States, applications are dominating the funding. Europe, really research is dominating funding.
Do you think that Europe can still be more competitive?
Many scientists come back to Europe from the United States nowadays, and the number of scientists who go to the United States is not very large, but they usually come back again. They go to the United States to show I have international experience, to show I have been in a great institution, and come back then afterwards as professors.
What about the communication to a wider public?
I'm relying on people like you who transfer the knowledge which we produce to the public. So it's important, and this is actually realized by all institutions. For this reason we are here essentially, to transfer the information which we scientists are producing to the general public. Mostly it's done by people who have some understanding of science, but more communication style.
As a professor, you meet a lot of students, early stage researchers. Do they perceive also this importance of transferring, or are they concentrated mainly on their research?
They are concentrated on their career, yes. Because in order to reach a position where you really can influence the public, you have to have a certain level. So young people don't have time for that. except there may be some young people who are very environment oriented, who do this on the side as a hobby.
Professor Bauer, it's been really a pleasure to have you here, to have had the chance to talk to you and to hear about your experience, your job, and your activity as scientist. We really wish you to have great results from this research.
CERIC.
And we hope to have the occasion to talk to you again after you will have concluded it, after your second experiment at the XPS.
It was a great pleasure to be interviewed by you.
Thank you
Thank
very
you,
much.
thank you.